On the 11th of December 2025, I did an Ask Me Anything session with BrowserStack. Part of that was streamed live to LinkedIn as a video, and then there was a Q&A session on Discord. Rather than type in all the answers, I thought I'd record them, because then that would be easier for me to capture my thoughts and get a live thought process. So what I'm doing in this recording is that you'll get the actual raw recording and thought process that I went through when answering the questions, rather than a polished video covering answers to typical questions. You'll get to see the raw thought processes and stumbling as we go through, but hopefully this is useful. And the questions are always interesting because these are real world questions that people are struggling with normal everyday activities, trying to figure out how to make sense of when to automate, how processes can work. And I always appreciate getting hold of these type of questions to then generate answers from my perspective. I try not to give prescriptive answers, and I try and deal with the system that people are going through and explain the thought processes that I try and use. So hopefully there's some value in this session, and it's going to be slightly different. So the question is, if I'm building my first test automation framework, what's the one thing about automatability I should understand early? So I guess what we should understand about automatability is that it covers our ability to automate, right? Take that one word, split it into automate ability. And that is the most important thing. If you really have the ability to automate something, you're not as dependent on the tools. You can create workarounds. You have a choice of multiple tools you want to do because you know how to structure, automate code. You know when to use an off-the-shelf tool, when not to. You know how to build abstraction layers to make it maintainable. So that ability to automate, your ability to automate, is the first thing to understand. That is the most important part of the process of automating something. Like, we often try to rely on tools to do things, but then you are completely dependent on the tool. You are completely dependent on the tool interacting with another tool, which is your system. Workarounds are harder. So if you can automate, if you have strong ability to automate, you have gained experience in how to automate, you can automate pretty much anything. You can automate things that other people can't, and you will much more readily succeed. It's not, automating is not about tools. It's about your understanding of what and how to automate and the ability that you're developing and practicing to automate that application. So next question is, how do you separate automation problems from application design problems? Teams often confuse the two. An application design problem can cause you problems when automating because some features are harder to automate than others. If you've got a state-based system, it can be hard to track that state over time or be able to possibly jump to a different state depending on how the application is built. I guess the way that I separate it is, if it causes me problems when I'm automating, it's an automation problem. It might well be an automation problem that is triggered by an application design problem. And that doesn't mean that we have to change the application design. It might mean that we'd have to figure out how to automate that application design. It may be something that we haven't encountered before. It may be something that our tools can't handle. If we have an event-based system and we haven't figured out how to trigger those events on the event queue, that's something we have to figure out. It might be something we have to extend our tool to do. But they are completely separate items. So if teams confuse the two, then I think the general rule is, if you are having problems automating, then it's an automation problem. And if it's triggered by an application design problem, you either have to absorb it because you're not going to change the application design and figure out how to automate it, or figure out how to automate it at a different level so you don't have to automate it at an end-to-end level, or maybe you can move it into a testing process and handle it through observability using tools like Datadog or other observability tools. So next question is, when dealing with slow UIs, is the slowness a testability issue, an automatability issue, or both? So the answer to that is it's probably both and more. It's a usability issue. If it's a user experience issue where a slow UI impacts the user's ability to do something, it's much more likely to get fixed and addressed than if it impacts your ability to test it or your ability to automate it. Because one thing is, if the user's fine, then it's working good enough for them. When we are testing or automating, and this is a concept that comes from cybernetics, need to have the requisite variety to handle the variety in the system that we're testing. So if it's slow, we need to have the ability to handle that. We need to know how to synchronize. We need to possibly look at what is causing the slowness. Maybe we need to clean up the environment before we test to make it run faster. But it really depends what the impact of that slowness is as to whether it's something we have to do. And it might also not be the application that's slow. It may be what we're choosing to test. In my test pages application, there are moments where a message is displayed to the user, which stays visible for 10 seconds and then fades away. My tests around that are slow to execute because they do something, wait for the message to appear, then wait for it to disappear. And that slowness means my test takes longer. Now, I don't have to wait for it to disappear. I could just say, is the message appearing? But I need to have at least one test, which is checking, does the image appear and disappear? So that variation in how I approach the situation is important. But if it's an issue, it's how it's impacting you, then, because it's not the slowness that's the issue, it's what the impact of that slowness has, and that's what we have to try and address. And that's where the concept of, do we have the ability to absorb different speeds or different response times in the application or not? If we don't, then is it something that we can develop either personally or in our tools? And if it's not something we're prepared to accept, then we might need to do something about it. So the next question is, how do you handle third-party widgets like payment gateways that are inherently not automation friendly? So there's a couple of things to unpack there. One of them is not automation friendly. That might mean not automation friendly for one approach to automating it. Perhaps it's not automation friendly for automating through the UI. But perhaps if we took all the cookies that were in place at that point and issued the HTTP requests that the UI makes, then perhaps it's easier to automate. So it's not necessarily that it's automation friendly. It might become easier to automate if we adopt different tactics. But the other thing is, it's a third-party widget. We may not necessarily have to automate it. What we might need to do is trust that it works and check simply that we have embedded it within our system effectively. Maybe we don't need to automate the full flow through that widget, but we need to make sure that that widget has been wired up correctly with our application. So maybe we only need to go partway through the flow to check that wiring up. And maybe we only need to put in some details, hit the first step, and if that first step is accepted, then we know we've wired it up, and then we rely on the third-party widget flow taking over. If we get to the point where that's all we have to do, then perhaps we could add a mock or a stub into our environment so that we don't have to test that widget all the time, and we simply have one place that we check the wiring up. It's about looking for what are the issues with automating it, and do we actually have to automate that in the first place? So the next question is, how do you evaluate an application's automation readiness during consulting? Do you follow a framework? So I guess there's two parts to this question. One is the consultancy framework approach, and one is applications automation readiness. So let's start with the consulting framework first. I do not have any frameworks for consulting. The closest I have is something called the meta model from neurolinguistic programming, which is an analysis of the types of questions that psychotherapists use when they are trying to understand what the patient they're dealing with is going through and how that patient models the world. So it's really a set of questions to build a model of the world. Because my consultancy approach is build a model of the environment that people have and compare it with the model of the world that is the reality that they're facing, i.e. the issues they've got, the processes they're using, and then try and make sense of that. So that's my consultancy framework. The next part of the question is the concept of automation readiness. Something is ready to automate as soon as someone wants to automate it. May not be easy to automate at that point, and it may be unwise to automate a lot of it at that point. But readiness is more about, are you prepared to commit to whatever it takes to automate this application at this point in time for whatever you want to get out of it? What are the reasons that you want to automate it for? Are you ready to take the consequences of attempting to automate it, regardless of what the application state is? And I guess that's the question that you would ask to evaluate an application's automation readiness. So next question is, what architectural patterns do you see repeatedly failing when it comes to large-scale UI automation? That's such a hard question, such a big question. Because the hard part is, are we thinking about architectural patterns in the automated execution code, or are we thinking about architectural patterns in the application that we're trying to test? So if it was architectural patterns in the automated execution code itself, the biggest issues that I see are, in fact, it's not really an architectural pattern, it's more just the team not having the ability to automate effectively, and the team blaming the tool when there are problems, rather than knowing how to work around limitations in the tool or just known limitations about automating in general. I guess one architectural pattern might be trying to maintain separate environments. That can be hard if you are not using the same install process to set up your test environment as you do for production, which isn't really an architectural pattern, it's a process pattern, a process anti-pattern. Do you deploy differently into different environments? Another one would be test data maintenance, trying to use production data in your test execution, or any data really that you don't control. If you don't have control over the data, but you automate to specific data conditions, then your test automation will fail, possibly randomly because you haven't controlled the data that sets up the conditions that you need. But all of this can be worked around. So if you know what issues you're failing, you come up with a strategy to deal with it. If you're working with production data, rather than hard code your tests against data, you hard code your tests against data conditions, and then you select the data to use in this test execution run, given a set of conditions, a set of select statements to pull back the data that you want, and you work on that data. And then you assert relative to the incoming data rather than a specific hard-coded expected outcome. So I think I would just keep answering that question if I keep on this. So it's a big, big question. And that's probably all I really have to say on that. So the next question is, if testability improves debugging and automation improves scale, how do we prioritize them during sprint planning? So that's hard to answer because I would first of all have to agree with the premise that testability improves debugging and automation improves scale if I wanted to answer it in that way. For me, testability is a range of factors, one of which is our ability to test, and one of which is the timescales we've got, one of which is the application ready to be tested? Do we have the tools and skills available? So I don't know what you have in mind for the word testability says that it improves debugging. To me, debugging is a programming task and is improved by the way that we structure the code. But let's focus on how do we prioritize testability and automation during sprint planning. So I think all prioritization during sprint planning is what we want to be left with at the end of the sprint. How much coverage do we expect from having automated and how much coverage do we want from having tested it? And planning for that so that we deliver something that needs to be tested in the sprint extensively early in the sprint. Potentially, we could be testing and automating in parallel. Hopefully we are. Potentially, we are automating at low levels so that we don't need to automate as much at the higher level. We don't need to automate as much for the UI because we've automated more at the unit level. But prioritization is something that teams have to wrestle with based on what they want as outcomes. And very often the issue is not so much the prioritization, it's when a team is split into roles that don't interact effectively. And one role is expected to, like a tester might be expected to just do it, regardless of the timescales, and regardless of the point in time when something is delivered during that sprint. And sometimes the whole concept of sprints is thrown out the window and testing and automating is something that overlaps into the next sprint. So those are kind of process problems. And I guess we prioritize based on outcomes and the whole team is involved in that. So next question is, do modern frameworks like Playwright reduce the need for high automatability design, or is that an illusion? So that's a good question. I would never have really phrased that in my head like that. But to answer that question, yes, I think it's an illusion. The reason it's an illusion is that Playwright is designed to absorb variability in the application. But in an earlier answer, I mentioned cybernetics and requisite variety and the ability to absorb. Playwright absorbs variability by having a retry mechanism. So if something is not ready to click on, it retries until it's ready. It absorbs some variability in the interaction. If you're using something like WebDriver, you have to absorb that variability by creating a synchronization strategy such that when you click, the application is ready to be clicked. The different locator strategies that Playwright uses are also designed to handle variability. So trying to locate something by the visible text allows items to move around, to be changed from buttons to links. It allows to absorb some variety. With WebDriver, you could still absorb that variety, but you're much more likely to say, I want to click on this particular button with this particular text in it. WebDriver is what you use and other tools like that are what you use when you don't want your test framework to absorb the variety because you want to be notified that something has changed that you didn't expect. Playwright very often helps that you do not want to be notified when something small has changed. You just want the end-to-end path that you're trying to automate to complete. So I think Playwright is very, very good if you want to do agent-based type automating, where you want to go from one point through a series of actions to another point, and then you want to check the end result. I wouldn't really want to use it if I want to check small flows and make sure that each assertion that I want during that flow has been met. Because Playwright can hide issues that I want to see exposed. And even when you're using something like Playwright, you still need to create page objects. You still want to create domain objects, payload objects. You don't want to create a maintenance effort longer term just because you're using Playwright. Playwright has a lot of incredibly good pros going for it, and if it meets your workflow needs, but you still need to know how to automate and understand how to structure your automating to make it maintainable longer term and to optimize it for efficiency. So next question is, how do I explain to leadership that improving automatability is an investment, not a delay? So I guess it depends what you are trying to improve about automatability. Is it your ability to automate, in which case it's training for the team, in which case that's an investment in staff training? If it's we need more IDs in the UI in order to help us do UI testing, why would they view that as a delay? The only reason they would view that as a delay is if they don't value the automated execution coverage through UI execution possibly created by the test team. That might be because they see more value in having the test team just do testing and report bugs. Or it might be that there is already automated execution at the unit level that they are comfortable relying on. It's hard to know exactly what the specifics are. But if you want to convince someone that something is a state that they're not looking at, like this investing, doing what we want you to do to help improve automatability is an investment, not a delay, you would have to show the difference between if we have this and if we don't. Then you can see this an investment because there's a return on that investment. If it's preventing you doing something entirely, then the alternative, if we do increase the automatability, then we can do these things, and then we get more value. I think it's showing that alternative world and comparing it to the current one in a way that makes sense for your leadership. So next question is, we are exploring AI agents for our teams, and I want to know, how does the AI agent deal with dynamic elements like rotating banners, third-party widgets, or A/B tests? So I guess this depends on how the agent works, because agent can mean different things in different tools. So sometimes an agent will build a script to do something. It might build a script at a high level, it might build a script using BDD, it might build a script using code. So again, depending on what it does, depends on how it deals with it. If it's using a BDD approach, then that BDD is going into the agent as a kind of runtime specification. And so the agent handles it because every time they automate, they work from scratch. They try to fulfill the requirements of that scenario based on what is in front of them at that point in time. So they just handle it. because it's the first time they're seeing it. If a pop-up happens that wasn't there before, they don't care. They just clear the pop-up and move through because they're trying to deal with an objective. If it's written code, then this is where all the tool vendors' concept of auto-healing comes in. Auto-healing doesn't mean auto-healing. It means I will automatically amend the script based on what is presented in front of me, regardless of whether it is right or not, because I have an objective that I'm trying to achieve. So again, it changes it to try and move forward. And the next time, if the pop-up doesn't appear, then it auto-heals such that the script doesn't deal with that anymore. Agents tend to operate on first principles, and that's how they deal with these things. It's one of the reasons why using an agent can be more expensive than scripting it, because it's not a deterministic code input. It's a specification input that is interpreted during the execution process. So the question is, what early signals tell you that a feature will become flaky once automated? So that's interesting. So if I'm looking at a feature on a page, I'm looking for an understanding of the synchronization points that the tool provides by default. So if it's Playwright, then Playwright has a lot of retries, so I might not be as concerned about how a page is rendered. If I'm working with WebDriver, I know that WebDriver synchronizes on waiting for all the assets in a page to be loaded, but it doesn't synchronize for all the JavaScript in the page ready event to have finished. So if I know that a page is being populated by JavaScript, I'm going to expect it to be flaky if I do not synchronize properly on that DOM buildup. So essentially I'm looking for, is the page and the component ready at the start, or is it being amended by JavaScript over time? Does it change? Are there visible indications that it has changed, like a spinner, in which case it's very easy to synchronize on, in which case it will probably be less flaky. But if it happens in the background without an easy way of knowing that it's finished, like say I update a checkout, a basket, a cart on a shopping cart, and it updates totals. If there are multiple items in the shopping cart, does it update multiple totals? How do I know which order the totals are being updated in? Should I synchronize on the final total changing? What if the final total doesn't actually change because I've adjusted the values in the middle to be the same? It's that update process that is the signal that it might become flaky. And also, which environment is it running on? There might be delays in processing based on the local environment versus the test environment versus the production environment. I just experienced that this morning, where the application I'm working on it behaves more slowly in the staging environment that it does on the local environment. So I'm going to have to adjust the synchronization that I use for that. Different environments. So the early signals are, does it get updated? But I'm looking at the architecture and trying to understand, how does this fit in with states, and how do I know that those states have finished? And it's not so much when will it become flaky, it's more, will it require synchronization to prevent it becoming flaky? And do I know how to synchronize on that? And if I find it very hard to synchronize on it, that's when that concept of automatability might come in, where we add an extra flag to tell us that it has finished updating the DOM and we're ready to proceed. So the question is, in microservices setups, which layers should teams focus on first to increase overall automatability? That's interesting. In the general layer that we should always focus on first is our understanding as humans of the architecture and what it is that we are trying to automate. Because then we can identify, do we have the right tools? What setup will we need in order to automate effectively? The interesting thing about microservices, given that's the example, microservices can be completely isolated and sit there communicating over HTTP messages, in which case that should be pretty easy because we know that we have HTTP messages. If they are complying with a version standard, then it's simple. We just comply with that standard. If the microservices are completely owned by teams and it's internal, which is the interfaces between those microservices can change on a kind of random basis, that might be a problem. Because then we would expect to see issues in production that we don't expect if we haven't tested end to end. If the microservices are event-based and there's some sort of queue in place, then we have to make sure that we can automate that queue, and we have queues in the test environment that match what we want, that our tools can send messages into those queues. So the layer that I'm looking at when I look at that question is the interface layer and our ability to automate it, and trying to keep it standard, because we're not just trying to automate from one microservice to another and possibly putting a queue in the middle. We're trying to have a secondary system that is not maintained in lockstep with those microservices, the test execution system, and that has to be updated at the same time. So having versioned interfaces is probably something to look at, or look at a process whereby when the microservices update, when the interfaces the microservices use update, we also keep the execution coverage up to date by creating effective abstraction layers. Some teams would immediately look to contract testing, but I don't necessarily think that's necessary when you have a process that takes into account the changes that can happen and you maintain the automated coverage and the abstractions that it uses effectively. One thing that I would avoid is replicating the objects, the interface objects from the microservices in the test code themselves. Like payload objects, don't take them direct from the code into the test, because then your test will continue to just keep running, but you may not spot issues that happen because you haven't accounted for some of the new fields that are added into those interfaces. It's like when people use protobuf and they automatically update the interfaces from a central code base. Whilst everything seems to work, it works at an interface level, it may not work in the consuming or the follow-on step from that interface level because there's a new field or a field got removed. We don't want to have our test execution coverage automatically update when the application changes, because we want control over that coverage and to understand what it's supposed to do. So the question is, for a team with limited budget, which problems around automatability should we fix first to get the fastest return on investment? To me, that's an easy answer, in the sense that what we want to look for with automatability is our ability to automate. The more that we can enhance that and improve that, the better your entire automated execution approach becomes, because you can create workarounds, you can create alternative situations, solutions, you can use multiple tools, you can use different techniques to automate because you're identifying when can something be data-driven and when do we have to split it out. For me, the absolute best thing for a limited budget, just in general, any automating activity, is to improve your ability to automate. It's not about tools. It's not about getting expensive tools. It's not about getting multiple tools, multiple languages. It's improving your knowledge and experience of how to automate, which is about training, but primarily it's just about practicing and experiencing and exploring the tools that you do have, exploring their capabilities, making sure you understand them, making sure that you're removing any impediments to automating effectively. If your tests are flaky, understand why they're flaky, fix the root cause of the flakiness. But all of that actually comes from improving your ability to automate as much as possible. So next question is, how can developers and testers collaborate earlier to avoid expensive rework on automatability issues? It's sad sometimes that we still have these questions because, I know that people go through this in the real world, and it annoys me that people have to go through this because it's such an easy problem to solve. Like, collaboration is such an easy thing to do. We collaborate when we share a goal. We collaborate when we work as part of the same team. We can easily put barriers between collaboration by isolating people. So we create a test team, we create an SDET team, we create a test automation team, we create a programming team. And these people sit in different buildings, or they work with different rhythms, they have different sprints. It's very easy to put barriers in place. And the way we collaborate is by removing those barriers. And it's as simple as that. So how do we get people to collaborate earlier? By looking at what barriers are in place that stop that collaboration early and trying to figure out how to overcome them. Now, most of the teams that I work with don't really have this issue because they're small teams that work together. You can easily get this issue if you have a test team that is working independently of the development team. At which point, I do not consider the development team to be a development team. They are a programming team. A development team has responsibility for the design, the programming, the product, making it suitable for the user, the testing, the putting it into production. So developers encompasses the entire set of roles in the software team. As soon as we have roles and we split them into silos, we get these issues. So I guess practical steps you can take are, if you are working independently as an automator from the programming team, you can get the programming team involved in the automated execution to try and maintain it, to make sure that we are automating what we need to, because if they are programmers, chances are they're doing unit testing. If you are doing unit testing at a UI level, then you remove a lot of the hard to automate issues that you experience when you're doing end-to-end testing, because you already have data IDs in there. The earlier that you try and automate something, the more you have to make it easier to automate. And the more that we share the responsibility for maintenance, the more that people will understand the issues associated with that maintenance and will resolve those issues. So it's not necessarily an easy answer because it's a people and process answer more than anything else. So the next question is, how should teams think about automatability when shifting towards continuous delivery and trunk-based development? So this is interesting in that this is the type of environment that I normally work. We have continuous delivery. Don't always have complete trunk-based development, but I normally work in environments that don't use a lot of branches, or they use branches for very short-lived features that get merged in very frequently, because the features are small, so they can get merged in multiple times a day, and we don't have long-lived branches. Which means we do have to have a lot of automated execution coverage that runs quickly. And the way we do that is by having the responsibility for that coverage to be part of the creation of the feature. So that when you are writing the code for a feature, you are also trying to figure out, how can I demonstrate to other people that this will work? Because the automated execution coverage, which typically we call unit tests, the unit tests that we create during feature creation are not just there to test the feature. They're there to demonstrate to people reviewing the pull request that we have tested the feature and we have created some overall checks that in the future, other people know that they have not impacted this feature when they make their changes. So it's not so much about automatability, it's about automated execution coverage. And the automatability there is, how can we automate the application within a sprint? We do that by making the person or the pair who are responsible for creating that feature responsible also for adding in the automated execution coverage. And then we have a review process that checks the coverage of that automated execution coverage. The automatability comes in by, how are you structuring your unit test? A lot of the time when people do test-driven development unit testing, they focus on a class level. So then your unit tests become very hardwired into the structure of the underlying classes. If you create classes at a domain level, like a user or an order, rather than the low-level classes, then you get some degree of end-to-end tests within the application at a domain flow level. Then you might look at the domain concepts of a checkout process, which is different from an order and different from a user because it combines both of those into a flow. So then you get the start of, just by testing at domain level, flow tests without actually having to do end-to-end flows externally to the system. So that concept of automating at a domain level might be part of the automatability concept that you need when working on that basis. So it's not just class-based unit tests anymore, it's domain-based unit tests. Then trying as much as possible to do interface-based tests. Try as much as possible to architect your application such that you can test your interfaces, your HTTP interfaces, without making HTTP calls. Because you have controllers, you have domain logic, you have the routing that converts things into domain objects, which represent the HTTP request in an internal fashion, so that you only ever need to make a few HTTP calls to test that interface. The rest of it you can do at the domain level. Architecting your application to make it automatable at lower levels is how we do this effectively with short feature delivery times and more continuous delivery, deployment, integration, and trunk-based development.